What is the divide and conquer pattern? Hello, my name is Eric Normand, and these are my thoughts on functional programming. So, there's a common pattern for implementing algorithms in functional programming called divide and conquer. And I'll give you an example. So, if you're going to calculate the length of a linked list, the recursive way of defining that, the standard functional way, is you check if the list is empty. If it's empty, the length is obviously 0. And if it's not empty, the length is 1 plus the length of the rest of the list. Now notice how in both cases, all you have to do is determine if it's empty or not. Right? In both cases, then the operation is trivial. There's no decisions to make after that. There's no looping, there's nothing. It's just a simple case analysis and then a trivial return. So in the first case, when it's empty, trivial return is 0. In the second case, it's 1 plus the calculation over the rest of the list. So this is the first principle of first principle that needs to be true to apply this pattern. And that is that the small cases need to be easy, because you're dividing the problem. That's where the divide and conquer comes from. The divide, so you're dividing the problem up into small problems that are each easy to calculate. Often they're trivial to calculate. There's almost no calculation. Okay, so then the second part that you need is you have to be able to combine the answers of those trivial problems in some way. Okay, and so in this way, in this example, we're combining them with plus. So we're doing 1, which is the length of the list, of the length of the head of the list, and then plus, and then the length of the rest of the list. Okay. Now, if you have some operation that happens to be associative, which means that the grouping doesn't matter, it means you can actually split the problem up arbitrarily. In this example I just gave, the list was split into 2, but 2 in a very specific place, which was it's split in 2 right after the head, right? But you could split it in 2 right in the middle if that is better for your particular data structure. In this data structure, a linked list, it is the best way to split one off at a time. Okay, so let's look at another algorithm and then apply these principles to see how we can do them. So we got this divide, get to an easy problem where it's trivial, and then put the answers back together. All right, so let's say we are looking for a value in a list. We just want to know yes or no, is this value in this list? All right, so let's say we can break up a list arbitrarily. So it's more like an array with random access. We want to find the trivial cases where it's almost no decision to make. All right, in this case, we want to handle obviously we need to handle the empty array. So if it's an empty array, the answer is obviously this value is not in the array, so it's going to be a false. In the case of an array of one element, all we have to do is compare the value we're looking for with the element. If they're equal, we return true. If they're not equal, we return false. So a tiny little decision there, right? It's still trivial. There's no like logic about searching or anything like that. We have one thing, we're comparing it to another, we're done. Okay, and so then in the other case, it's going to be where we have not 0, not 1, but more than 1. We're just going to split. Okay, we're not going to do any real logic. We're just going to split. We're going to divide the problem and then recombine the answers. So how do we divide the problem? Well, one thing we could do is split the array in two. Okay, so we'll just figure out where the middle is. Like, so to take the length of the array, cut the array in two separate arrays, and then recursively find the element or the value in that list on the left, and recursively do it on the right. And then we'll recombine them. And when we recombine them, we have to figure out what operation we're going to use. And in this case, it's going to be OR. Did we find it in the left? Yes, great, we're done. Or we didn't find it, let's look in the right. Right, so it's an OR. An OR, as we know, is associative. The grouping doesn't matter. If there's any true anywhere, regardless of how you group, it's going to give you the same answer, true. Otherwise, it'll give you a false. And so those are, in that algorithm, those are the three cases. The empty array, trivially false. The one element array, which is trivially just compare the value to that one element. And the more than one array, which is simply split it in two, recursively call it, and OR them together. So another thing that we notice is that in both of these cases, and I believe it's true generally, the identity value for the operation that we're combining is what we use for the empty array. So in the case of the count, the operation we were using to recombine the answers was plus. And so when we had an empty array, we used 0 as the answer for that. And in the case of finding a value, our operation was OR, and so we used the identity of that, which was false, when we were dealing with the empty array case. And I think this applies generally. So if you take it as a whole, this pattern, this algorithmic pattern, requires those three things now. You need an operation that is associative so that you can split the problem up arbitrarily and regroup it later, regroup the answers later. You need a problem that can be split up into smaller trivial problems, and you need an identity for those very trivial, the super trivial problems like the empty array. All right, so that just about does it for divide and conquer. I'd love to hear what your favorite divide and conquer algorithms are. I think it's a really useful pattern, especially when you're dealing with recursively defined data structures, because it really works. The recursion works really well, but it also works on other kinds of things besides lists and vectors and arrays, and it doesn't have to be on a data structure. It can be on any kind of problem that can be split. So for instance, you could, if you wanted to, you could determine whether a number was even or odd by dividing it in two recursively. If you get a 0, then yes, it is even. If you get a 1, then no, it is odd, and then you AND them all together. So if anybody returns a 1, you have a false, your overall answer is false. So anyway, let me know what your favorite divide and conquer algorithms are. Let me know the most outlandish way that you can do divide and conquer, even when it is probably not the best way. I'd love to see some pretty crazy uses of this pattern. And you can tweet me. I'm Eric Normand on Twitter. You can also email me, eric@lispcast.com. All right, see you later.